right, so let's say we have two, I guess you can call them parabolas. Well, when you have two parabolas, you have what they call hyperbolas. So with a regular parabola, you have one vertex, but with a hyperbola, you have two vertices. So you have a vertex here and a vertex here. Okay. Now with this one, let me check, make sure I got it. If you have a center point, then you have a slant asymptote. Uh-oh, that's supposed to be straight. That goes through the center. And just like any other asymptote, you just have it to where that graph won't cross that line. So let me draw the next one. Okay, so this asymptote will go on and on and on in that direction, on in that direction, but it won't cross those asymptotes. Okay, and just like with let me move this down a little bit. Make that vertex here and move that vertex over here. Because just like with a regular parabola, you also have a focus point. And we'll put that there. But in this case, since you have more than one, you have a plural version of that, which is a foci. So really, it's kind of like a double parabola. Okay. So whenever you have the two horizontal asymptotes, well, whenever you have the two vertices, I guess that would be a better explanation of it, of horizontal vertices. Okay, so whenever your vertices are horizontal, you have a horizontal asymptote. Now the formula for this asymptote is x minus h squared over a squared minus y minus k squared over b squared equals 1. And of course for this one, your center is HK just like before. Okay. Now for this, you want to notice that the x term is positive and it's over the a squared. And the reason you want to notice that is because it changes for vertical and horizontal. And over a squared. Okay. Now the formula for the focus points is going to be when you're starting from your center, h plus c k and h minus c k. Okay. So you can see from there that the focus point is the distance from the center. I mean, c is the distance from the center to the focus points. Okay. So c equals the distance from the center to the focus points. Now a is the distance from the center to the vertices. Okay. So if you wanted to find the formula for the vertices, you just replace the C with A. Actually, let me do that now. H plus A, K, and H minus A, K. So really the same formula, you're just switching the A and C. Okay. Now if we went through the entire proof and everything else, which we're going to skip, I'll add the notes to the proof, but you don't really need it. We know that C squared is equal to A squared plus B squared. Where in this case, you can solve for B, where B is equal to the square root of C squared minus A squared. Okay. Now for this one also, and I'll go back up in a second, remember here and here you have your slant asymptotes. Okay, those are the barriers that that graph will not cross. Right. And you have a formula for those. That's y equal plus or minus b divided by a. Uh-oh, should be y minus k. Sorry about that. X minus h. Okay. So those are the formulas you'd need for your horizontal hyperbola. Remember, that's just when the vertices are both horizontal to each other. Let me bring this up a little bit so you can see a little more of the page. Here we go. All right. So any questions so far? All right. Okay. So now we're going to do the vertical hyperbola. We're going to compare the two so you can see really they're quite similar. Okay. Make sure that's up enough. So really it's the exact same thing, but instead of the parabolas being side to side, you have one on top of the other. Okay. And just like before, you have your two vertices. So you have a vertex here. And you have a vertex here. And just like before, just like with the regular parabola, you have a focus point here. And you have a focus point there. Probably should have gave that a little more room. But your center is right between the two vertex points. And just like before, your slant asymptote goes through the center in both directions. Okay. Now the formula for this one is just a little bit different because you're going to swap the y minus k and x minus h. So you have y minus k squared over a squared minus x minus h squared over b squared equals 1. And just like before, the center is still hk. Yep, clean that up a little bit. Okay. Now on this one, you want to notice that the y is positive and over the a squared. Okay. And the reason I wanted to make sure I point that out is because here, you notice when the x is positive, your vertices are along the x-axis. But when your y term is positive, your vertices are vertical or along the y-axis. Okay, so the y term is positive. And over the a squared. Okay. So in most cases, if they do give you the formula, you'll be able to figure out what your a, which one's your a and which one's your b, by which one is in front. The a and the b, a squared and b squared, does not change. Okay, so now for this one, your focus points, you notice when it's horizontal, it's h plus c, h minus c. But when it's vertical, it's k plus c, k minus c. Because remember, if it's shifting, it's going either up or down. Okay. Now, the one thing that's exactly the same about both is that C is the distance from the center to the focus points, and A is the center from the vertex to the focus points. Those two are the same for both. Oh, and the vertex is actually, let me put that mark there. HK plus A and HK minus A. Okay, so that's the distance from the center to the vertex. C, again, is the distance from the center to the focus points. And the one way I usually remember that is C is in focus point or foci, so that's the one way I used to remember. Where again, C squared is equal to A squared plus B squared. And in a lot of cases, if we have to solve for B equals the square root of C squared minus A squared. We don't always have to solve for b, but in some cases we do, and that's pretty handy to know. Okay, and just like before, we have a formula for the slant asymptotes. Okay. Now, if you remember from the horizontal, it's y minus k equals plus or minus b over a x minus h. It's the exact same formula. You're just going to switch the b and the a. So y minus k equals plus or minus a over b x minus h. So you can see the formulas are really close to each other. Just that if it's vertical, your k value is going to change for your vertex and your focus points. And if it's horizontal, your x value is going to change. Like I said, I'll apply the proof, not apply, but supply the proof for all of these. You don't have to know them at all. Just if you're curious, they'll be in the scan notes. Just that for the most part, they usually take about 20, 30 minutes, and you really don't have to know it, so that's why I'm skipping over it. All right, so we're going to now apply these to solving the problems. All right, so let's say, for example, I want to find the standard form of the equation of the hyperbola with focus points -1, 2, and 5, 2, with your vertices (0, 2, and 4, 2). Okay, so if they give us that, we should be able to find the formula. I mean the equation. Okay. So what I normally do is whenever you get the points, I would graph the points, and this way I would know whether or not it's horizontal or vertical. Because if the vertices are left and right, you know it's horizontal. If they're above each other, well, one is above, one's below, you know it's vertical. So plot the points. Doesn't have to be specific, but kind of helps you visualize. Okay. So if we have -1, 2, and 5, 2, let's say this is -1, 2, and this is 0.52. You don't even have to draw the x-y axis and all of that. You just need to know where they are. Okay, so those are your focus points. And your vertices, remember, they're just inside. So that's 0, 2, and 4, 2. Okay, so we know if these are your vertices, That's going to go like that. Not like that. Well, it'll look a little bit better, but hopefully you get the idea. Okay. So we know just from here that it's horizontal. Okay. So if it's horizontal, that means we're going to use the x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay. So that means we have to find a, b, h, and k. Does that make sense so far? All right. Now, actually, there are two ways you can find your center. If you know these are always going to be the same distance apart, you can say, okay, well, the center is halfway between those two. So you can kind of count it out, 0, 1, 2, 3, 4. So you have 4 spaces, so you know it's a distance of 2 on each side. So you know that's a distance of 2, and that's a distance of 2. Or you can just use the midpoint formula. But usually if you can visualize it and do it this way, it's faster. But if you just wanted to figure it out, you can use midpoint. And if you remember, that is just x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So we can actually use that to find our A and our C. And then once we have our A and our C, we can solve for our B. Okay. So say to solve for the center, we can actually use either the 2 vertices or the 2 focus points. Either one will give us the same center. Okay. So let's say if we have our x, we'll use the focus points. Just because. Okay, so that's our x1, x2, and y1, y2. So we have -1 plus 5 divided by 2. And we have 2 plus 2 divided by 2. Okay, which gives us 4 over 2, which is 2. And 4 over 2, which is 2. Okay, so that actually gave us our center. Like I said, if you wanted to, you could have just drawn out the points and kind of figured it out from there. That halfway is 2, so that would be on the same line, 2, 2. But that's if you didn't draw it out. Okay. So we know the distance from our vertices to the center. We know that's 2. We figured that out already. So our A is equal to 2. Okay. Now, if you want to go the distance from the focus points to the center, you just get the distance between the two. So you have -1, 0, 1, 2, 3, 4, 5. So that total distance is 6. You divide that by 2, you have 3. Or if you wanted to, you could use the midpoint formula again. Nope, not vertices. Focus points to the center. Yep. Okay, so that means our C is equal to 3. So we have our H and our K. We have our A and our C. The only thing we don't have is our B. But if you remember, C squared equals A squared plus B squared, so you can solve for B. Okay, so we have that. Since C squared equals A squared plus B squared, that means that B is equal to the square root of C squared minus A squared. We don't need the negative since you're not going to have a negative distance. Okay, so that means that B is equal to the square root of 3 squared minus 2 squared. Okay, so square root of 9 minus 4, so B is equal to square root of 5. Excuse me. Okay, so we have our A, we have our B, we have our H, and we have our K. So we just get all of that and plug it in. Make sure it's okay. So we plug it into our formula, x minus h, so you have x minus 2 squared over a squared, so that would be 2 squared, minus y minus k, which again is y minus 2, squared over b squared, which is, where do b be? Square root of 5. So square root of 5 squared equals 1. Now, if you wanted to simplify that, you could. So x minus 2 squared, instead of 2 squared, you could have it over 4. Minus y minus 2 squared. Instead of square root of 5 squared, you can just make it 5. Equals 1. Okay, so each problem should tell you exactly which form they want it in. All right, so any questions on this one? All right, since that's getting ready to shut off anyway.